Welcome everybody. Today we're going to learn how to use the Pythagorean theorem with isosceles triangles. Now before we start with this video, it is very important that you watch the video before, which is Intro to the Pythagorean Theorem, so that you know what we're talking about. Now, let's get started. Okay, so here we have an isosceles triangle, and we have that this side right over here has a length of 8 units and that this side has a length of 6 units, and we're asked to find x, which is the height of the triangle. Now, first of all, what do we know about isosceles triangles? Well, we know that there is a smaller side and then two larger sides that have the same length. And 8 is bigger than 6, so 8 would be the larger side. And since we have two of those larger sides that have the same length, this other side right here would also be 8. Now, this height right here, if you didn't already realize, kind of splits the triangle in half, leaving us with a right angle here and a right angle here. And notice that these two angles are also congruent, and that these two other angles that this line forms are also the same. So therefore we can conclude that this triangle right here and this one right here are congruent. So you might be asking, how would you use the Pythagorean theorem to find the height of this isosceles triangle? Well, we would split the triangle in half. So we would split the triangle in half and we would get a right triangle. The right angle will be over here, and this side right here is going to become the hypotenuse, which is going to be 8, and then 6 is the length of the whole base of the isosceles triangle, and since we're splitting it in half, it's going to be 6 divided by 2, which is going to be 3. And then we have x, which is the height. Now, we're going to let x equal b so that we can plug it into the Pythagorean theorem formula and understand it a little bit better. So let's go down here. Now, what do we know? We know that 8 is the hypotenuse, so it's going to be C. We have that 3 is the shortest side, so it's going to be A. And we defined x right here, so x is going to equal B. So we would now have 3 squared, which is A squared, plus B squared equals 8 squared, since it's C squared. Now we would simplify this right here, and we would get 9 plus B squared is equal to 64. Now we would subtract 9 from both sides to isolate the variable, and we would get B squared is equal to 55. Now we would take the positive root from both sides, since we cannot have negative distances, and we are left with b is equal to the square root of 55. So b is also equal to x. So now we know that this height right over here is equal to the square root of 55. And we also now know that the height of this isosceles triangle, the original one, is equal to the square root of 55. Okay, so here we have another example. But instead of finding the height, it is asking us to find the base of the isosceles triangle. So, as I said before, we know that this triangle and this triangle are congruent. So we can go ahead and split this isosceles triangle into two, and we would get this triangle right here. This 13 would become the hypotenuse, which is C. Then we would have this 12 become B, and then we have x, and since we split it in half, it would be x over 2. So you can think about x over 2 being a. So x over 2 squared, which is basically a squared, plus 12 squared, since it's b squared, equals 13 squared, which is c squared. Now we would simplify this, so this would be x squared over 4, since 2 times 2 is 4, plus 144 equals 169. Now let's scroll down and solve it. So let's subtract 144 from both sides to leave x by itself. So we would get x squared over 4 is equal to 25, which is 169 minus 144. And then we would multiply both sides by 4 to cancel out the denominator right here. Both sides by 4, and you would get x squared is equal to 100. And now we would take the positive root of both sides, because once again you cannot have a negative distance, and you would be left with x is equal to 10. X is equal to 10. So now we know that this side, the whole length of this side, is 10 units. And that is another way you would use a Pythagorean theorem to find the length of an isosceles triangle. Now let's do one more example. In the other two examples, we were finding either the height or the base of the isosceles triangle, but in this case, we're going to solve for one of the two greater sides. So let's get right into it. So, as I explained before, we would split the triangle in half. We would split the isosceles triangle in half. In this case, I'm going to use the right half to solve for this side right here. So 18 divided by 2 would be 9, since we're splitting it in half. And then we would have 12, since the height stays the same. Now, remember that the Pythagorean theorem formula is a squared plus b squared equals c squared. Now this is going to be c, since it is the side opposite to the right angle. And now we would have 12 squared plus 9 squared equals c squared. Now let's simplify these two squares, and we would get 144 plus 81 equals c squared. We would add these two and get that 225 equals c squared. Now we would take the positive root of both sides, since we can't have negative distances, and the square root of 225 is a perfect square, and it's going to be 15. So we know that 15 equals c. And now therefore we know that these two sides are 15. Thank you so much for watching this video. Like and subscribe, and see you next week.